Right then, so this is the video with examples on integration by parts. Integration by parts is this formula here in the top right hand corner, which I'll show you where that comes from in class at some point when I get back. Now basically, integration by parts is like the product rule for integration. Okay, so we use it to integrate products. So we start off with this example first. The integral of x cos x. So we're going to let u equal x, and dv by dx is going to be equal to cos x. We just follow the formula in the top right hand corner. So obviously we're going to need to work out du by dx, which is just going to be 1. And we're going to need to work out v by integrating cos x, which we know is sin x. Okay? So then we just substitute that in to the formula. So the integral of u dv by dx, which in this case is x cos x, is going to be equal to uv, which is x multiplied by sin x, so it's these two, subtract the integral of v times du by dx with respect to x, so it's v times du by dx is sin x times 1, with respect to x. So to finish it off, we just have to integrate that sine of x term. So therefore, our integral is going to become x sine x subtract negative cos x, because sine x integrates to negative cos x, plus c. Remember the plus c in this one because it's indefinite integration. So we use our arbitrary constant. That'll be x sine x plus cos x plus c. Done. Okay? Let's do another example then. Alright, so this time we're going to integrate x squared times log x using that integration by parts formula again. Alright? Now this is a little trickier, okay? So if we let u equal x squared and dv by dx equal log x, then when it comes to, so du by dx is going to be easy, that's 2x, but if we have to integrate log x to get v, then can we do that? And actually the answer is we can't. At the moment we don't know how to integrate log x, we haven't got a value for it. Okay, so all we're going to do is, if you've got a product with log x in it, we just swap them around. We let u equal log x because we can differentiate that to get du by dx, and we let dv by dx equal x squared because we can integrate x squared. Okay, so when you've got a log term, let u be the log term. Alright, so we've got u equals log x, dv by dx equals x squared. So that's going to give us du by dx is equal to 1 over x. So we've dealt with that easily this time. And v is going to be the integral of x squared, which is x cubed over 3. Okay, and then we stick all that into our by parts formula. So that'll be I is going to become, so u times v, so uv, which is in this case x cubed over 3 multiplied by log x. Subtract the integral of v du by dx, so it'll be x cubed over 3 multiplied by 1 over x dx, where the x cubed and the x in the bottom cancels out, leaving us with an x squared term. I'm also going to take out the third at some point. X cubed over 3 equals log x. Subtract, like I said, we'll take the third out on the next line. X squared over 3 with respect to x. Alright? Yeah, so that third we'll just bring it out, so we only have to integrate x squared then. Just makes it a little bit easier. So that's going to be x cubed over 3 multiplied by log x, subtract a third integral of x squared dx. So almost finished. So that's going to give us, so therefore I is going to be x cubed over 3 log x subtract a third x cubed over 3, and don't forget the arbitrary constant, plus c. So let's shift that up a little bit. So if we simplify that, then we've got, therefore, I is going to be x cubed over 3 multiplied by log x, subtract x cubed over 9 plus c. Done. Okay, quite simple actually. It's a bad name, integration by parts. It's actually not too bad as long as you do a lot of written working out. Okay, now in the previous example I said we can't actually integrate log x, but using integration by parts we actually can. So let I equal the integral of log x with respect to x. Okay, so same as before, we're going to let u equal log x, and in this case we're going to let dv by dx equal 1. Okay, so obviously there's a 1 in front of that log x. Alright, so if we work out du by dx and v, we get du by dx is equal to 1 over x, and a v obviously is going to be equal to x. Okay, so now put that into the formula, we'll be able to work out what the integral of log x is. So I is going to become u times v, which is x log x, subtract the integral of v du by dx, so that's going to be x multiplied by 1 over x. So that's going to be x multiplied by 1 over x with respect to x. Obviously the x's are going to cancel each other. So that's going to be, therefore I is equal to x log x, subtract 1 with respect to x. So therefore I is equal to x log x, subtract x, plus c, don't forget. Okay, so there you are. Integrating log x actually isn't that difficult a thing to do. Okay, as long as you know how to do integration by parts, obviously. So that's x log x minus 1 plus c. Okay, so there you go. You now know how to integrate log x. Okay, there's another video after this one, just some slightly more difficult examples you can look at, watch before you try the exercise if you want, or try a few questions on the exercise and then watch the next video to help you with the remaining ones. Okay, good luck.